Hello, Algebra 1 students. This is going to be on section 9.1, factoring and solving quadratics. Because of the coronavirus, my wife is sitting here next to me, and she might be laughing while doing this video. And so if you hear hysterical laughter, it's because she's laughing at how bad this video might be. There she is. She's already laughing. Okay, so what we're going to do in this video is we're going to factor a quadratic and solve a quadratic as well. Using the factoring techniques that we've been working with the past couple of weeks. Let's first go to do number 1 here, and hopefully again you printed these notes already so that way you can follow along. If you did not print the notes, you're welcome to put this on a separate piece of paper. So number 1 and number 2 look kind of the same. It says with the following terms, write an expression in standard form. Number 2 says with the following terms, write an equation in standard form. So there's a difference between the expression and an equation. So let's do the first one. An expression in standard form would be something like 3x plus 2 plus x squared. Or you can put it in any order that you want. If you want to do x squared plus 3x plus 2, that's fine. If you want to change any of those pluses to minuses, that's also fine. Please note we cannot combine those terms. These two are going to stay as trinomials. Now, the difference between number 1 and 2 is one little symbolic piece. So we could take either of these expressions or equations, but the one thing that we're going to have to add to it, and I'll take this purple one. So we'll take x squared plus 3x plus 2 for number 2. What we're going to add to it, though, is this 0. And we're going to say that it equals 0. And this is an equation. An equation contains an equal sign. And because we have an equal sign now, we can actually solve for x, so we can answer the question. So what's the difference between an expression and equation? Let me type that for you because my handwriting is atrocious. Let's see here. An expression is a collection of variables and numbers. An equation is an expression that also contains an equal sign. And again, when you contain that equal sign, there's going to be something on both sides of the equation. Let me just change the color. I'll change it to my favorite color. We'll change this to this cloudy shade of purple. Okay, next. So now we need to know what is the zero product property and how does this help to solve quadratic and factor form. So the way we're going to do this problem is currently we already have a factored form here. So this is already factored. And whenever we have factors set equal to 0, what we can do is take each of those factors and set it equal to 0 individually. So for instance, we can take this 2x minus 3 and set that equal to 0 and solve. How do I solve that? Well, do you know how to solve this, Rachel? 2x minus 3 equals 0?
Plus 3.
She knows it, and she hasn't done math in about 15 years. That's amazing. So you're going to add 3 to both sides. That's exactly right, Rachel. Rachel is the name of my wife. All right, so we're going to add 3 both sides. We get 2x equals 3. Divide by 2 on both sides, and we get x is equal to 3 over 2. Or if you plug it in your calculator, you're going to get 1.5. And this is one solution to the equation. Let's do the other one. We'll set x plus 5, the other factor, equal to 0. And when we subtract the 5 here to solve for x, we get x equals negative 5. And these are my two solutions to the equation. And basically what I use here is I use a zero product property, which means that when I have factor form equal to 0, that part's worth repeating. When I have a factor form equal to 0, I can set each factor equal to 0 and solve for x. So let me just put that on a new page to tell you what that means, just so you can see it again. So the zero product property allows you to take a factored form that is set equal to 0 and break up each factor to solve for x. Each factor is set equal to 0 and solve for x. So again, if I had 3x minus 5 and x plus 2, and in this scenario we had equals 0. Uh-oh. Technical errors, technical errors. Okay. Then what that means is I can take now 3x minus 5 equals 0. Equals 0, and I could also take x plus 2. And I don't need the parentheses necessarily. Equals 0. And then I can solve for x in each one. And I'm going to remove the parentheses in each of these. And this again is called the zero product property. Okay, another example of how the zero product property works. We're going to be using that a lot from now on. And since we're 5 minutes in, let's go and keep going here. So now we're going to factor and solve the following quadratic equations. So just as a reminder for ways that you can factor, and Mr. McConey did this yesterday in the video, you could do a GCF, you can do the Foster method, you could split the middle. All of these are potential methods to solve the quadratic equations and solve for x. Just a reminder on what a quadratic equation is in case you're not sure, because there is a lot of vocabulary here. A quadratic equation is an equation that has a square in it. And a square will look something like this. And yeah, that's it. So in number 5 and number 6, I'm going to have you pause and try it on your own. But number 5, 3x squared minus 6x equals 0. I can take a GCF out on both of these of a 3x. Remember that 3x comes on the outside of the parentheses. And 3x squared divided by 3x is just 1x. Negative 6x divided by 3x is going to be a negative 2. And on the other side equals 0. And with the zero product property, I can set each factor equal to 0. So I can do 3x equals 0. And how do I do that? I think I divide by 3 on both sides. So x is equal to 0. That's 1. And then I can do this again with x minus 2 equals 0. And when I add 2 on both sides, I get x equals 2. And what that means is if I plug in 0 and 2 back into the original equation, I would get 0 out. And that's one way I could check my answer. Let's do this again. So x squared plus 2x equals 35. What I'm first going to ask you to do before I ask you to pause is make the equation equal to 0. And that part will take you a long way in your math. Take an equation and set it equal to 0. I'm going to put that in red because that's super important. Make equation equal to 0. Okay. So here we made our equation equal to 0, so go ahead and use the Foster method here to try to factor and solve for x. Please pause the video and try it on your own. Please pause the video now. Please pause the video. Okay, hopefully you tried this on your own. The Foster method means you need something times something to equal negative 35. You also need something and something plus something to equal a positive 2. I believe those answers are going to be 7 and negative 5. Which means that our factored method is going to be x and an x. And then it looks like we're going to have a plus 7 and a minus 5. And this should still be equal to 0. And now that I have two factors equal to 0, I can use the zero product property. What was that method called, Rachel? The zero product property is what she said. She did not say no idea. And that means we can set each factor equal to 0, which is x plus 7 equals 0. And we can also set x minus 5 equals 0. So we set both of these equal 0. And then we solve for x. Subtract the 7, and x equals negative 7. So this is really just one more step that you have to do for what we had done the last few weeks. Okay, x equals negative 7, x equals 5. If you got that correct, please go ahead and raise your hand so I can see who got it correct. Hope you didn't raise your hand. That'd be silly. All right, let's go on to the next one. All right, so now we're going to So now, my wife liked that joke. That was a funny one. So now we have 4 more problems. So now I'm going to ask you to go ahead and pause and try to solve these on your own by using any factoring method that you know to try to solve for x. I'll give you some hints here, just so we can get started here. Number 7, I believe you're going to need a GCF, and you're going to need a Foster method. For number 8, you're going to need to split the middle. For number 9, it looks like you're going to need a factor by grouping. And number 10 is going to be a difference of 2 squares. So please pause the video and try those problems on your own. Okay, so hopefully you're able to try those problems. Here's your answers for number 7. You had to take a GCF of the blue 2x out, and you're left with what's inside the parentheses, x squared minus 9x plus 18. And then after you get that part, leave the 2x on the outside and factor the highlighted part with the Foster method using this part right here. And hopefully you were able to get x minus 6 and x minus 3. And that gives you 3 answers. 2x equals 0, x minus 6 equals 0, and x minus 3 equals 0 is the zero product property. And you get 3 answers of x equals 0, x equals 6, and x equals 3. And again, if that went too fast for you, you're welcome to pause the video and kind of stop and see what you might have done in your own work that may have been different. And again, if you're still not able to figure it out, you are welcome to do the Google Hangouts that we have posted on Schoology, so you can get a more one-on-one approach with it if you need. For number 9, you need a factor by grouping, and I chose the area method. So I put 9x cubed, 18x squared, minus 4x, and minus 8 all in a box, in their own individual box. And I looked at the GCF for each row and each column, and I ended up getting this part, the 9x squared minus 4 and x plus 2. And then I said each factor equal to 0 and solve for x. Sorry about that. And then I said each factor equals 0 and solve for x. And that got me x equals negative 2 over 3. Oh, I'm sorry. After that, I forgot about this one. This was kind of a hard problem. 9x squared minus 4 was actually a dot, so I could factor one more time to get 3x plus 2 and 3x minus 2. And then when I said each factor equals 0, I got 4 answers. I got x equals negative 2/3, x equals 2/3, and x equals negative 2. And again, that was just setting each factor equal to 0 to solve for x. For number 8 was here. You needed to move the 3 over number 1 because you always want to set this equals 0 before you factor. And I had to multiply a times c together. If you weren't sure what a and c were, it was 4 and negative 3. I multiplied those together to get a negative 12. But then I also was looking for something added to get 11. 12 and negative 1 worked for me. So what I did is I factored by grouping, by splitting the middle. So that's where that 12x and minus 1x came from the 12 and minus 1. And then this time I didn't do the area method, I did the algebraic way. And I found a GCF out of both groups, which was 4x for the purple, minus 1 for the red. And I combined them to be those factors down here. And then, so that's those factors there. And then I said each of those factors equals 0 because that's a zero product property, and I got x equals 1/4 and x equals negative 3. And the last problem was 49x squared minus 25, and I did some side work here to show you the square root of each one, which was 7x and 5. And then it's the same numbers, opposite signs, so you got 7x plus 5 and 7x minus 5. Set both factors equal 0 and solve for x. And I got x equals negative 5 over 7 and x equals 5 over 7. And again, if you did not do well with any of those, or one of those, or a couple of those, or however many you did not do well with, you are welcome to go into a Google Hangout and chat with a teacher about it. You're also welcome to reach out to your friends and see how they solve the things of that nature. But please don't feel like you're all alone in this part. The very last part says to look at a quadratic whose solutions are x equals negative 3 and x equals 2. So because we only have about 20 seconds left here, you're basically given this. If you add both sides of 3 again, you get x plus 3 equals 0. And if you subtract the 2 here, you get x minus 2 equals 0, which means the factored form is x plus 3 and x minus 2. And you could go backwards one more time to get the equation, and I'll leave you to multiply that out because you would have to multiply that out by multiplying that out. That's all I'll say. And you would get something like this. But because this wasn't the focus of the lesson, I'm not going to spend too much time on that. Thank you for watching, and have a good spring break.